Alright, in this video we're going to be talking about arithmetic sequences. A sequence is a list of numbers that will form a pattern as you go from one number in the list to the next, all the way as far as you want to continue your list. Every item in the list or in the sequence is referred to as a term. So far what I have is, in my example, a sequence that has 3 items in it, 12, 8, 4, and the sequence is formed by subtracting 4 from each item in the list. So I could continue this pattern, and I would have a 0, a -4, a -8, -12, -16, and so on. Okay, so far I've found the first 8 terms in the sequence. I can find more terms in the sequence by using this formula. And in this formula, you're going to have to know what some of these items are. A sub n refers to the value of an item that you're looking for. So if I'm looking for the 14th item in the list, whatever that number is, that's a sub n. A sub 1 is the first number in the list, or first item in a sequence. N is the position of the item you're looking for. So if I'm looking for the 14th number, n would be 14. And then D is the common difference. In our example up above, the common difference is -4, because I keep subtracting 4 from one item to get to the next item in the list. So let's say it would be pretty easy for me to keep this pattern going 14 times. Let's say, though, I wanted to find the 50th item in the list. Okay, so I want to know what the value of the 50th item is in the list, so a sub 50. The first item in our list was 12. 50 is the position of the item that I'm looking for, and the common difference is -4. And when that D is written right next to those parentheses, that means I'm going to multiply the common difference, but whatever I get when I do n minus 1. So n minus 1 is 49. 49 times -4 is -196. And when I add 12 to -196, I get -184. So the 50th item in the list is -184. Okay, we don't use that formula just to find numbers that are far down in a list. We can use it to find other things as well. For example, let's say I knew that the 100th item in a list was 64. And I knew that the common difference for our list was 2. I could find out the first number on the list just by knowing those values. So for example, the value of the 100th item in the list is 64. The first item in the list I don't know. I do know that 64 is in the 100th spot, so I need to plug 100 in there. And I know that the common difference is 2. So if I clean up and do some of this math here, 100 minus 1 is 99. 99 times 2 is going to be 198. And I need to subtract 198 from both sides. And I will find out that the first item in the list was -134. And if I kept adding 2 99 times, I would get up to the 100th item in the list, which is 64. Okay, so let's start with different information this time. Let's say this time I know that I know that the 15th term in the list is 49, and the first term in the list is 7. I want to find out what the common difference is that gets me from one term in the list to the next. So a sub n would be 49 because that's the value of the 15th term in the list. A sub 1 is 7, and 49 is in the 15th spot. I just don't know what the common difference is. So 49 equals 7 plus 14 times d. If I subtract 7 from both, I get, let's see, 42. And 42 divided by 14 gives me a common difference of 3. So if I kept the pattern going 15 times, starting with 7 and adding 3, I would get up to 49. And I'm not going to do that. There's no need to when we have a formula that can do a lot of that work for us. Okay, so let's say I know that in my list I have a negative 58 somewhere in my list, and I know that my first term is 5, and my common difference is negative 3. I just don't know where that negative 58 is located. Well, I can find out its position. Negative 58 is some number in the list. The first term is 5. I don't know what spot that negative 58 is in, though. And the common difference is negative 3. Well, I need to find out this n, and I can't solve for n when it's inside the parenthesis like that. And so I'm going to distribute the negative 3, which will give me a negative 3n plus 3. Now combining my like terms on the right-hand side, I have 5 plus 3, which is 8. If I subtract 8 from both sides, I'm going to have negative 66. And if I divide by negative 3, I find out that negative 58 would be in the 22nd spot in that list. Okay? Some other things that you can do with this formula. Whoops, I missed some of this. We'll get it. Let's say that I were to be given the first term in a list and the 5th term in the list, and I wanted to find those missing 3 terms in the middle. Some examples you could probably figure out the common difference just from the numbers that you're given, but in some cases you may not, especially if the common difference happens to be a decimal or a fraction. So what we're going to do, we want to find these 3 terms in the middle. They're called the arithmetic means. So when you're looking for values in the middle of a list or in the middle of a sequence like that, you're looking for arithmetic means. You might look for 2 of them, you might look for 4 of them. In this case, we're going to look for 3. So we know that a number farther in our list is a negative 7. We know that the first number in our list is a 5. And that negative 7 is in the 5th spot in our list. We just don't know what our difference is to go from 5 to negative 7. So now if I clean the math up that's in this problem, I should be able to find out what the common difference is. 5 minus 1 is 4. And if I subtract 5 from both sides, I'm going to get a negative 12. Divide both sides by 4. And my common difference is negative 3. So now I can use that common difference to find those arithmetic means. If I subtract 3, I'm going to get a 2. If I subtract 3 again, I'm going to get a negative 1. And if I subtract 3 one last time, I'm going to get a negative 4. So the 3 arithmetic means for 5 and negative 7 are 2, negative 1, and negative 4.